Hello everyone. Here we are going to see some concept related to subject microcontroller and embedded system, which is subject code is 18 CS44. In module 4, some of the concepts are already covered in the previous video lecture, like characteristic quality attributes. Quality attributes means we have two types, operational and non-operational quality attributes. And we already covered our embedded system application and domain specific concept, also hardware software co-design and program modeling. We seen some of the modeling concept like DFG, CDFG, state machine, FSM, like this, sequential also. Then embedded firmware design and development concept also completed. But some of the related to this embedded firmware design and development concept, we've seen some of the things. One is selecting the model, and that is somewhat some fundamental issue related to this hardware software co-designs. That is an important issue, is selecting the model, selecting architecture, selecting language. That are some of the main issues. So out of that, how to select model, that we've seen in the program modeling concept. And about embedded firmware design and development, some of the approaches we've seen here. Now in this video lecture we are going to concentrate on some of the language using to design that particular model. So what are the language we are using, different types of language and their construction, that thing we are going to see in this video lecture. Now here textbook we have to refer for more information is this Introduction to Embedded System, which is written by this Shibu KV, second edition textbook. We have to refer for more information about these topics. Now here embedded firmware development languages, how to select language, that thing is one of the issue in your hardware software co-design. So there here related to that concept, we have one concept that is called embedded firmware development language. What are the different language we have here listed? One is assembly language or low level language, high level language, and combination of assembly and high level language. These are the three different methods we are using as is to select a language. We are using different methods. What are the language? One is, first is a low level, or it is also called that is example of low level is assembly level language. We will consider that first one now. Assembly language actually that is called low level language. That is example of a low level language. And in the lot of microcontroller we are going to use our low level language, because that low level language or assembly level language having a lot of advantages compared to high level language, and anyway disadvantage also there. But well, what do you mean by low level and what do you mean by assembly level? Here thing is you have to concentrate about a low level. Why? Because here all the codes whatever we are writing in assembly level, in order to write we have to concentrate, or we have to know what is the register size, and what is the memory size of the processor, and how many registers, how many register numbers, out of that how many general purpose, how many special purpose, and what are the instructions we are using, and what is the size of the memory, and how many bit size, each register having how many bit size, and what is the instruction size, what is the data size. All information we have to know before writing any assembly level language. So that is the main thing in this method, that is a low level language. But in high level language, no need to know anything about register, memory, or your size of the register, everything. Just you can write your code in the editor window and you can execute that, so that your software itself just for that particular thing. But here you have to know that before writing code, because without register size we can't write code, without your memory size we can't write your code, also without any instructions also fixed there, so we have to concentrate on instructions also. So that is the thing related to your assembly level language, also called low level language. Here some of the things are given here. Assembly level language is a human readable notation of machine language. So that is a human can read assembly language, but human can't read this machine language, because machine language, you know, that is in binary format. Assembly language, we are going to use some of the set of instructions, and by using that instructions we are writing our entire assembly code. So this is assembly called human readable. And machine level language is not human readable, that means in terms of binary zeros and ones, and that is understand by processor itself, that machine can that is a processor understandable language. Okay, each line of assembly language program is split into 4 fields as given below. We have one assembly language or one assembly instruction, means we have these 4 fields. What are the one instruction contains? One is a label. A label means it is a just a label thing. You can user can give any name in this place, user defined part label, and that is a optional. If a user want, they can give name here, otherwise they can avoid this part. And we have another one that is called opcode and operand comment. Opcode means operation to be conducted or operation to do in the processor, that is called opcode. And opcode is a operation to do, that means either some of the instructions we have add, subtract, multiply, division, and compare, like that. There is a different types of operations to be done, that is contained in opcode. Then we have operands. Operands this opcode, that means operation we are going to perform on operand. It is, we can call it as a data. So either in this place we are putting directly data, or we are using register in the place of operand, and inside the register we have data, or either we are going for memory in this place, operand place. Inside memory we have data. Anyway, we are going to concentrate mainly data in this place, because operation performed on the data. So operation to be done is opcode, and operand is either register, memory, or directly immediate number. And next we have comment line. So comment also optional, so that is represented by semicolon, then you have to put comment. In the C language, then we have slash, like that. Here we have semicolon part, semicolon, then you have to write comment. And one here about operand, another point is there. So either you can use only one operand here, or two operand, or three operand also possible. More than one operand we have to use in this place, that is a operand part. Opcode means operation to be done. So this is a complete format for your assembly level instruction. Label optional and user defined, and opcode is predefined, and there we have operation to be done, and here we have data or memory or register in this place, that is a 1, 2, or 3 we have operand, or 2 or 3. And comment line, if any user want to add comment, then he can go for comment line with the semicolon, and in order to understand this instruction, human or a person or user can give particular comment line in front of that particular line. And here another one, that is a assembly level language, that is a low level language, and human understandable language. But processor will understand only binary language. So human understanding language is can't understand by processor. That's why we need to convert our human understandable or low level language to your binary format, or it is a machine level language. We have to, that is called machine level language. Processor understandable language is called machine level language, and that form is that is a binary format. Zeros and ones contain inside that machine level language. So how to convert that your low level or assembly level to machine level? So there we are going to use one of the tool that is called assembler. Assembler is a tool that converts your low level or assembly level to your machine level. So that is a very important part in the case of assembly level language, that is a assembler. So here we have one diagram, and this diagram which converts your source file to object file. So how your source file is converted to object file, so that part is given. So the object file is represented by extension .obj, and source file is represented by extension .src, that is a source, or .asm. Normally we are representing by using .asm. Assembly level is .asm itself. We are going to save that program with the file name .asm. Here condition thing is given by using block diagram. Here we are writing our code either in any of the software. We are using Kale software also, or you can use some DOS software, DOS box. So there we are going to write our assembly level language or low level language by the extension .asm, file name .asm, and that is called your source file. And that source file is just human understandable language is there. You have to convert into machine understandable language. How to convert that? We are going to use some assembler for that. Assembler is used in low level language, and compiler is used in high level language. So assembler will convert your low level language, that is a source file, to one object file. Okay. So here many source files are there, means all source files are converted into object file by using assembler. Assembler is a free software or paid software. So assembler is a tool we are going to get in free in the internet, or you have to pay sometimes you have to pay, or there is a license also sometimes. So depend on assembler thing, you have to convert. The why we are using assembler means mainly converting this .asm to obj. And here we have two obj files, .obj files, object files, and we are going to include a library file also. It contains some of the library things, library items, that means instructions, library instructions, and everything is combined together. And we are using another tool called linker or locator, linker bar locator. This is another tool which converts your object file to absolute object file. I will tell you why object file to absolute file conversion is required. So your linker or locator will convert your object files to absolute object file. Absolute object file is converted into your machine code by using another tool. We are using some other tool in all of these softwares. We have that tools. One is assembler, one is a linker locator, one is this object to hex file converter. That tools are there in that particular software. So that particular tool will convert your absolute object file object to hex file. Hex file is a perfect machine code with the all address specified in that uh, file itself. For particular instruction, address also specified. So like this, we have complete perfect machine code or hex file here, and that is ready for execution. That means you can dump this code for the embedded system for execution purpose. Now this is your set of diagram, that is a block diagram, which converts the source file to object file translation. Now related to this, we will see some of the points here. Some assembler are freely available in the internet for downloading. Okay, that I already specified. Some of the available freely, some of the assembler you have to pay, and some of the assembler there are cracked version or licensed version is also there. So you can download that and you can install that, and you can convert your low level language you written in any of the software to machine level language. Each source module 1, that is here module 1 means in the previous diagram we have here source, this one they given. So each source module 1 written in assembly, there is a source file written in assembly and stored as .src or .asm. So normally if you are writing in assembly level language, so that is represented in .asm, but generally they are telling us source file, that is a .src. Once you saved that, then on successful assembly of each .src or .asm file, a corresponding object file is created with the extension obj. So conversion is done by using assembler, which converts your .asm file to .obj file. The object file does not contain the absolute address. This is the problem we have there. So object, whatever you converted from low level language or .asm file to .obj file, that obj file does not contain any absolute address. The address is not specified properly of where the generated code need to be placed on the program memory, and hence it is called a relocatable segment. So it is not specified properly. Which is not specified properly? Absolute address. Absolute address means where the generated code need to be placed on the program memory. So that particular thing is not specified in your .obj file. It can be placed at any code memory location, and it is the responsibility of the linker locator to assign the absolute address for this module. I think now you understood why we are using linker and locator. So in order to the responsibility of the linker and locator is assign the absolute address. In the previous case we don't have absolute address, so your linker and locator job or that tool job is to assign the absolute address for that particular module. So absolute object file is used for creating hex file for dumping into the code memory of the processor controller. So you have to dump your particular code into your kit. So in order to dump, we need a particular .hex file. So that is a perfect machine code or machine language file. So how to convert your absolute object file to your .hex file? So that concept, this is a final stage in the conversion of assembly language to machine understandable language. So there is a final stage which converts your object file to or absolute object file. Absolute object file means your entire instruction using in that particular code contains address. Address means where it need to place it in the program memory, that also contain in that. So that is called absolute object file. Hex file is the representation of the machine code, and the hex file is dumped into code memory of the processor controller. So hex file is your machine code now. Final machine code, you can call it as a hex file. Hex file means actually it is a file name .hex. So hex is a extension, that is a not file name, just that is a extension of file name dot extension, like you have .asm, .src, .obj, we have .hex. Here why hex means inside that everything is hexadecimal numbers. Machine code and hex file is dumped into code memory of the processor bar controller. You are dumping into that. Hex file representation varies depending on the target processor controller make. Okay, depend on the processor, that hex file representation is different. Hex file created from the final absolute file using object hex file converter utility. That means we are using some tool. That tool in the previous slide we can see we are using one tool is assembler, we are using second tool is a linker bar locator, we are using third tool is to convert absolute object file to machine code. So these are the three tools we are using to convert your .asm file to .hex file. So this is the perfect source to object file translation diagram. Now I will show one of the small example here. So they written some assembly language and they shown here debug method. So first we have editor. Here you can see in this diagram editor program is there. So editor will just you have in this place you have to edit your program, that is a low level language, and you have to save in .asm, myfile.asm. So extension file should be .asm. Once you return that file and saved in .asm format, then we are using another tool that is called assembler. Assembler is a tool which converts your .asm file to some object file, .obj file. Not only obj file, it actually assembler will develop one .lst, that means extension is .lst, that is a list file, and crf means it is a cross reference file. Also with this we have .obj file, but we need mainly obj file because list cross reference that are contain some of the symbols, some of the address, everything. So obj file we need that. So your linker bar locator will convert that object file to some execution file, that is a .exe. Okay, obj file is converted into .exe file by using linker bar locator. So here with the linker bar locator, that means the linker bar locator tool will generate execution file. Along with that we have .map file also. Okay, so extension is .map, that is a map file. So like this this is the execution of your micro processor or microcontroller assembly level language. So like this we have here one of the example, that is a debug window. So one of the microprocessor code is executed, and here that execution window or debugging window is shown here. So you can see here we are using some of the things. First myfile.exe. So before that, here we are going to start our execution. First we have to enter our thing, then source file, then you're going to get object file, list file, cross reference file, that means this part. Okay, before that we are going to put myfile.asm, then you are going to use your assembler. Which assembler we are using? Macro assembler, that is a which is developed by Microsoft, that is used here. And then you are getting, once your assembler will convert obj, list and cross reference file, so you are getting another thing, that is zero error, zero warnings, also severe error also not there. So what is the next job is to convert obj file to your exe file. Okay, so here we are going to use that linker we are using, that will convert your obj file to your exe file. Along with that we have library file and map file. So map is a map file and library file lib. So all are the extensions. So once we got this, then our code is executed properly. So actually in this case we are using another tool to convert your absolute file to machine code, but this complete setup they shown here with the .exe file. Okay, so now this is about your low level language or assembly level language. So now what are the advantages related to that? It is efficient code memory and data memory usage. So it is efficient, memory optimization is there. So very efficient code memory and data memory usage. So code memory which stores your instructions, and data memory which stores your data related to your program. Then we have high performance. Your assembly level language performance is high. Okay, low level language performance is high. Another very good advantage is the low level hardware access. All low level hardware, we have two types actually: high level, low level, middle level. That hardware, so all accessing the hardwares are very easy in this assembly level language. Low level hardware access are easy. So these are the main three advantages of your low level language. But what is the disadvantage, or that is called as a drawback? So here, high development time. It takes a lot of time for developing your code. Okay, that is the main thing. Second thing is a developer dependency. It is completely, that assembly language is completely depend on developer. So who will develop that code? That person can develop any type of code. So depend completely on developer. If that developer written wrong code, means that program also wrong. So it completely depend on developer. So last, another one is a non-portable. Non-portable means we can't change. That means in one of the PC, that particular software, that is a low level language, is working, means we can't expect the same software work in another laptop or another PC. That is called non-portable. We can't move that. Moving means just we can't install that same. Here one of the PC we have 64-bit processor, means there we are going to get that installation, but in another PC maybe we can't get. So it is a non-portable. We can't just shift to that same software in another PC. We can't expect that. So that is called non-portable. Assembly language based programming is highly time consuming. It is a very high time consuming, tedious, and require a skilled programmer with the sound knowledge of the target processor architecture. Also, application developed in assembly language are non-portable. Okay, so these are the things we have in the uh, low level language drawbacks. Now we will move to another one, second one, that is a high level language based development. So compared to low level language, here we don't have much difference. The most common used high level language for embedded firmware application development is C language. So C language is low level, not low level, it is a high level language. So we are using a lot of examples are there for your high level language: C, C++, Java, like this. So program written in any high level language is saved with the corresponding language extension. So that is a .c, .cpp, C++, etc. So here program, any program written in high level language, so we have to save in this format itself. So C++, C, many high level languages are there. You know about that: Python, Java, all are high level language. One of the main thing is between low level and high level, here no need to know about any hardware thing, that is about registers, about memory, anything. We no need to know that things before writing code. So that is the advantage, we can call it as in a high level language. But that is a disadvantage in low level. There we have to know everything before writing code. So that is in low level. So translation of high level source code to executable object code is done by cross compiler. So you know compiler, but what is cross compiler? Cross compiler is another compiler we are using in your embedded C programs. Embedded C is different, C is different. There is some difference between that two languages, and that is not perfect C. So some difference is there. So for embedded C we are using cross compiler, and for basic C we are using only compiler. Here we are going for high level language based. So you can see, as is same as assembly language, we are using one block diagram representation of converting source code to hex file. So here we are going to use the source file, that source file extension. In the previous we saved everything in .asm, but here we are going to see save everything in .c format, and that is converted into object file by using cross compiler. Cross compiler will convert your main source file or your high level language file to object file. So with that we are going to add a library file also, and combinedly that we are using one linker bar locator tool to convert this into absolute file, object file. That is I told in the previous slide why we are converting into object file to absolute, because here object file we have all instructions and machine format, but address for that particular instruction is not mentioned in the object file. So here in the absolute object file, absolute address for that each instruction is mentioned. That mention happen by using that tool, that is a linker bar locator tool. And once that absolute object file we got here, so we need to get hex file. So hex file we have to get from absolute object file. Then at that time we are using another tool. That tool we are going to, by using that tool we are going to get our hex file properly. So this is a perfect code, perfect machine code. You can load that machine code into any embedded device. So this is your complete set of source code to hex file conversion in the case of high level language. Now what are the advantages? It reduces development time. So what are the disadvantage in the previous assembly level language? That is your advantage here. Okay, in the previous we had this is the disadvantage in the assembly level, but that is the advantage in the high level language. Here reduces development time. It reduces development time. Developer independency, there we have dependency, right? So here we have independency, that will not, that means particular code is not depend on any developer not dependent, that is a independent. And portability, you can port that particular C program or Java program to any of the computers or laptops or any embedded devices. Okay, that is a portable. So same version software is applicable to another embedded device also. So that is a portable high level language. So what is the drawback we have? So here time required to execute a task also increases with the number of instructions. Time required for executing the task, that means how many time required to complete particular operation, that also increases with number of instructions. As number of instructions also increases, time also increases. Then hardware access timing is critical. So this is actually your disadvantage, but this is solved by using assembly level language. Assembly language we can easily access your hardwares. There is an advantage in that, but here accessing the hardware is very critical. Okay, so that part is somewhat that is called as disadvantage in the case of high level language. Then investment required for high level language based development is high. Investment required is high, but investment required for low level language is low. Okay, so that there we have advantage, but here that is a disadvantage. Some compiler available for high level language may not be so efficient in the generating optimized target processor specific instruction. All compilers are not perfect, so while choosing compiler we have to think twice. Okay, while downloading we have to think twice. These are the drawbacks of high level language. Now we have another part. One is low level, one is high level, third one is mixed level, that is a combination of high level and low level. So in that combination we have three parts. So while mixing of high level and low level, we are mixing in three methods. One is assembly level language with the high level language. Second is mixing high level language with assembly language, and inline assembly programming. So anyway we are going to mix both high level and low level, because some of the advantages are there in high level and some advantages are there in low level. So we are going to take both advantages and we are going to combine each other, form a good perfect code. For that we are going to combine mixing. So what is a mixing of assembly level with high level? So we will see that mixing of assembly with the high level means just you are going to write some of the codes or some of the set of codes or 10 line 15 line code of assembly inside high level language, that is a C language. C is a just example I considered here. Example is assembly language with C. So we are writing some 10 line code of assembly language into C. So actually main code is C, but inside that or in between C program we are going to add some of the lines of assembly language. So that is called mixed assembly with the high level language. Assembly routine are mixed with the C in situation where the entire program is written in C and the cross compiler in use do not have built a support for implementing certain features like interrupt service routine function, or if the programmer want to take advantage of the speed and optimized code offered by machine code generated by handwritten assembly rather than cross compiler generated machine code. So here some of the advantages are there in your C language. So here they whatever they explained is assembly routine with the are mixed with the C. We are going to mix assembly language with your C language in situation where which situation where the entire program is written in C. You know that entire program we are going to write in C language, and cross compiler in use do not have built-in support for implementing certain features, because you are writing only in C program, but we missing some of the things. What are the things we are going to miss? So in order to avoid that missing things, we are going to add that assembly language. So assembly language we are mixing with the C language, then we are going to get some of the extra features, that is the advantages, that is the interrupt service routine function. ISR function is there in assembly. So while mixing we are going to get that thing in our C program. Or if the program wants to take advantage of the speed, yes, your low level is speed, right? Speed is high level is speed is less. So we can take advantage of speed after mixing and optimize it. A perfect code also we are going to get that small code offered by machine code generated by handwritten assembly rather than cross compiler generated machine code. Here we are going to use these three things while after mixing. Before mixing we won't get this thing in only C. After mixing we will get these advantages in this. When accessing certain low level hardware access is easy in the this one, which is assembly level language. That is the advantage in assembly, right? The timing specification may be very critical and a cross compiler generated binary may not be able to offer the required time specification accurately. This is the disadvantage, we can call it as in the mixed assembly level language. So after mixing you may get this error. Okay, there is a chance of timing problem is chances there. So timing it may be very critical, and a cross compiler generated binary means machine code may not be able to offer a required time specification accurately. There is a no accuracy for the time. So that is a disadvantage in after mixing, but this is the advantage. We have 3 points, but this is the disadvantage you can consider. Passing parameter to the assembly routine and returning value from the assembly routine to the caller C function, and the method of invoking the assembly routine from the C code is cross compiler dependent. So mainly what is a cross compiler? We are using to convert our assembly this mixed code to your main what is that dot hex file. So for that purpose we are using cross compiler. So cross compiler means this is used in embedded C thing, but compiler means we are using in pure C language. Okay, now passing parameter means there is a sum of the parameter passing from your low level language to high level. Anyway, we are mixing, right, 10 lines of assembly and 20 lines of C. So at that time, some of the parameter need to exchange between that C and your assembly language. So that passing parameter thing is somewhat complicated in the case of mixing part. So that we have to concentrate while selecting the cross compiler. Okay, now another mixing is high level mixing with the assembly. That means the C we are going to mix with the assembly language. So here basic code is assembly itself. So 20 line code is there, means out of that 18 line code is there of assembly itself. Some of the lines 2-3 line code is we are going to mix of high level language. That is here they given example C. The source code is already available in assembly language. Source code is assembly language, and routine written in high level language. Some of the subroutine, so 10 line or 5 line, like that small program we are going to write in high level language, and then we are going to mix. Like C need to be included in the existing code. We are going to include C in the assembly, but previous one we included C in, sorry, main code is C, there we included assembly, but here main code is assembly, there we are going to include C. The entire source code is planned in assembly code for various reasons, like optimized code, this is the advantage, optimized performance, advantage, efficient code memory utilization, that is also advantage, and proven expertise in handling the assembly. So these are the advantages after in the assembly. So in order to take help of that advantages, we are using this mixing method. But some portion of the code may be very difficult and tedious to code in the assembly. Some of the lines, because we are mixing, right, assembly and C, somewhat complicated lines also there. To include the built-in library function, and what is the advantage here? Again, what is the advantage of the C? Why we are mixing C with assembly? That advantage is here given. Built-in library functions, that is there in your C, so that advantage we are going to take here. And built-in graphics library function, that is also there in your C, so we are going to take help of that. And string operations are there in C, so we are going to take that help in the mixing part. So in the C we have these three advantages, so we are going to take help of that, and your assembly we have these advantages, we are going to take help of that. So both advantages combined together, then forming a perfect code here. Now third type of mixing method is either that is a inline assembly. Inline assembly means just not entire code we are taking, just one line, maximum 1 to 2 line we are going to take from another language. So inline assembly is another technique for inserting target processor controller specific assembly instructions at any location of the source code written in high level language C. So again here clearly they defined, so source code or main code is there in C. Okay, we are going to include some of the lines of assembly inside that your high level language. So inline means in the previous two cases, we are including your high level or low level in between, but that complete line is in one set. That is if 10 line code assembly we are going to include in C, that 10 lines are together and that is separate means we are going to include that in entire code, but that 10 lines are together. Okay, but another one C we are going to mix with the assembly, there also 10 lines of C are together in that entire assembly. So other codes of assembly are together, these 10 lines are together, but in this case inline assembly we are taking one line of assembly in 10th line of C, another instruction of assembly we are taking 12th line of C, then another one is 19th line of C. Like that we are taking randomly anywhere in the code of the C we can take one line of assembly language. So this is called inline. So here also we have some of the advantages, but disadvantages also there. Passing parameter is somewhat complication method is passing the parameter, how that particular parameter is passed from assembly to C to assembly, that is somewhat complicated. So advantage is there, that is hardware access and related things, and instruction is somewhat simple in the assembly also. So we can take only advantages and we can build our perfect code in this inline assembly. So while coming to next concept here, for you people, you have to know some of the difference thing, that is a differentiate between cross compiler and compiler, differentiate between compiler and assembler. These are the possible questions you may get in the exam. So my suggestion is just note down these things and search and write down some of the answers for this compiler and cross compiler. Mainly what is the difference between this, at least 2 to 3 difference you can note down. And compiler and assembler, again between compiler and assembler, what is the difference? Compiler we are using in high level language, assembler we are using in low level. And compiler and cross compiler we are using in embedded C, compiler in pure C. Then C and embedded C, so C is what is the difference, and embedded C, what is the difference? And high level language versus low level language, what is the difference? So my suggestion is to write some of the difference between these things. So it is helpful for your future as well as in your exam purpose also. So in these things you have to know, because this is general knowledge. You have to know compiler, what do you mean by compiler, what do you mean by high level, low level, what do you mean by embedded C and C. So just note down some of the difference, and thank you for this class.